Alright, hey guys, we're filming this video outside today because it's a lovely day. It's a little bright though, sorry about the shades. We're going to be talking about stable equilibrium and tipping points in today's video, so stay tuned. Our significant ideas in this video are that systems can exist in alternative stable states or as equilibria between which there are tipping points. And also destabilizing positive feedback mechanisms will drive systems towards these tipping points, whereas stabilizing negative feedback mechanisms will resist such changes. And we'll introduce that second idea today, but we'll really dig deeper in our feedback loops video. Okay, so first thing, let's talk about ecosystems. Now, we remember ecosystems are open systems, and as an open system, an ecosystem will normally exist in a stable equilibrium. Now, we'll talk about what that is in just a second, but it's going to exist in a stable equilibrium, a steady state equilibrium, or in one developing over time, like with succession when there's like new growth in a forest, which we'll talk about as well. And these are maintained by stabilizing negative feedback loops. So we'll talk about feedback loops in our next video coming up. But we're going to mention them here today as well. So let's talk about some definitions first. Equilibrium is a state of balance which exists between the different parts of any system. Think about equilibrium a lot when we talk about physics, but we'll be talking about equilibrium here in ecosystems as well. In general, most systems tend to return to their steady, balanced state after any disturbance. A stable equilibrium is the condition of a system in which there is a tendency for it to return to the previous equilibrium following disturbance. So it's just the stable state that it's going to keep getting back to its normal state, to its normal equilibrium. So we're going to use an example of like a bowl and a ball as like an example for stable and unstable equilibrium. Now, for our ball, which is our system, if it's nudged a little bit, eventually the ball is going to return to its original position after disturbance. If our bowl is in this position, that's said to be stable equilibrium. But if we flip the bowl over, we give it a slight little disturbance, whoops, it is not going to return to its initial position no matter what happens. And that's called unstable equilibrium. So with one little nudge, one little disturbance, that ball will not be able to return to its previous state. Now, a static equilibrium is when there is no change, and we don't see this very often in nature with living things, because with no change there are no inputs, no outputs. It's generally not living. So for example, a sofa or a rock would be in static equilibrium. It's not going to move. Now, a steady state equilibrium is the condition of an open system, and there are no changes over the long term, but there's tiny little oscillations in the very short term. So the overall system may experience small changes over time, little ups, little downs, but in general, there's not a lot of net change. That's a steady state equilibrium. So let's talk about some examples. Body temperature in mammals. I'm sure you've talked about homeostasis in biology, where all living things like to maintain a steady internal balance. For mammals, that steady internal temperature is going to be around 37 degrees Celsius. And when it goes below that, what our body has is our mechanisms to help bring it back